Let us start third unit in which we'll be studying exception handling, that is in the first part, and in the second part stream based IO, that is the built-in package java.io. So let us see here the first part of this unit, which is about exceptions. So what is an exception? So here an exception is an abnormal condition that arises in a code sequence at runtime. In other words, an exception is a runtime error. So a Java exception is an object that describes exceptional condition that has occurred in a piece of code. So when an exceptional conditional arises, an object representing that exception is created and thrown in the method that caused the error. So that method may choose to handle the exception itself or pass it on. Either way, at some point, the exception is caught and processed accordingly. So here in the Java, we have basically five keywords to handle the exceptions that are thrown by the sequence of code. When a programmer writes a program, sometimes we may suspect errors in some statements, the code written by the programmer. So the five keywords are try, catch, throw, throws, and finally. So these are the five keywords with which an exception thrown by the code written by the programmer can be handled, which is available in Java. So these are the five keywords. The keywords are try, catch, throw, throws, and finally. So we have seen similar words like finally. We have seen finalize method in the first unit and final a keyword in the second unit. So the finalize, when we were studying about garbage collection, we were talking about finalize method, and the final keyword in the second unit, when the variable value, if it is declared as final, its value cannot be changed in further programming. So that is the meaning of final, which was used in second unit. Now here we have a similar name finally. So we'll see what exactly these keywords try, catch, throw, throws, and finally meant. So here any the block of code um, which you want to monitor for exceptions must be placed under a try block. If an exception occurs within the try block, it is thrown. Your code can catch this exception and handle it in some rational manner. System generated exceptions are automatically thrown by the Java runtime system. To manually throw an exception, use the keyword throw. Any exception that is thrown out of a method must be specified as such by throws clause. Any code that absolutely must be executed after try block completes is put and finally block. So the exact meaning for these five keywords is, the first keyword try is the block of code, the statements which you want to monitor for exceptions must be placed under the try block. And if any one statement of the um, code which is placed under try block um, produces an exception, it is thrown, and whatever thrown by the statements present under a try block will be caught by the catch block. And an exception, if it is uh, automatically thrown by the Java runtime system. So to manually throw, we can also throw manually an exception that can be done by using throw keyword. So if a method present in the try block, if it throws an exception, that method must be specifically declared as throws class, and the type of exceptions that method throws, it has to be mentioned. And in the finally block, after completion of try and catch block, the final code which has to be executed after try and catch block, that statements must be placed under a finally block. So these are the meanings for the five keywords that are used for exception handling. So the syntax for try catch block is, so the block of code to monitor for errors must be placed under try block, and more than one statements if they are throwing errors, we need to have the corresponding number of catch blocks, uh, catch exception type 1 and catch exception type 2 and so on. And after completion of try catch block, the block that has to be executed must be placed under finally block. That is the syntax for try catch and finally block. We have different types of exceptions. So all exception types are subclass of the built-in class throwable. So we have figure as shown. So the throwable is the topmost class, and exception class error are the subclasses of throwable. Under exception class, we have runtime exception and IO exception. And these are the different types of exceptions that we come across in the Java programming. The Java built-in exceptions are broadly classified into two categories: checked and unchecked exceptions. The checked exceptions are those for which the compiler checks to see whether they have been handled in your program or not. So the checked exceptions, basically we can say they are handled by the compiler. So at compile time, whatever errors you come across, they are said to be checked exceptions. And unchecked or runtime exceptions are those which you come across during runtime. So the examples for checked exceptions are class not found exception, no such field exception, no such method exception, interrupted exception, IO exception, illegal access exception. So these are the checked exceptions which you come across at compile time, and unchecked exceptions which we come across under runtime: arithmetic exception, array index out of bounds exception, null pointer exception, class cast exception, buffer overflow exception, buffer underflow exception. So let us try a sample code where we have not used any all the five keywords to handle the exceptions, and assume that the code written by you throws some exception and how it is handled, let us see. And such exceptions are said to be uncaught exceptions. So the code here, class name is exe0, which has public static void main string arguments, and this method has integer d equal to 0, integer a equal to 42 divided by d. So a value is divided by 0. So when the Java runtime system detects the attempt to divide by 0, it constructs a new exception object and then throws this exception. This causes the execution of exe0 to stop, because once an exception has been thrown, it must be caught by an exception handler and dealt with immediately. In the above program, we have not provided any exception handler. In this context, the exception is caught by the default handler. The default handler displays string describing the exception. So when the above program is executed, you get the following output: java.lang.arithmetic exception colon slash by 0 at exe0.main at, within brackets exe0.java colon 4. So here exe0 is the class name, the method name is main, the file name is exe0.java, and the line number where we get the error is 4. So that's how the Java runtime system gives the output when the above program is executed. So now the same program when we try to use the keywords try and catch, and let us handle the exception thrown by the code. So using try and catch. So although the default exception handler provided by Java runtime system is useful for debugging, you will usually want to handle an exception yourself. Doing so provides two benefits. First, it allows you to fix the error. Second, it prevents the program from automatically terminating. So most users would be confused if your program stopped running and printed a stack trace whenever an error occurred. Fortunately, it is quite easy to prevent this. So to overcome the problem, mm, that when they automatically to stop the program to be automatically terminating, we can use try and catch block. Then that can be avoided. So here is the program, the same program in which we are using try and catch block. So class ext1 public static void main string arguments integer da. Under try, the as I said, the block of code that is to be monitored for exceptions must be placed under try block. So here d equal to 0, a equal to 42 by d system.out.println, this will not be printed. So this is placed under try block. And next to try block, since here only one statement throws an error, we need to write only one catch block. So catch, because the above a equal to 42 divided by d is arithmetic statement, so definitely it will throw arithmetic exception. So catch of arithmetic exception e, this block has println statement which has string division by 0. When the above program is, and after catch block you have system dot out dot println after catch statement. When the above program is executed, you will get division by 0 after catch statement. These are the outputs you get, because at this statement a equal to 42 divided by d, it is divided with 0, so you will get an exception. So at this point the control of program, the execution control will go to the catch block immediately. It will not be executed, this system.out.println, this statement will not be executed. The control will directly go to the catch block and this statement will be executed. Then after try catch block, this statement will be executed. That's why you are getting division by 0 and after catch statement. Now the above program can also be modified to display the description of an exception by catch arithmetic exception e system.out.println under double quote exception colon plus e. So when the above catch block in the above program is replaced with this catch block, the output, when that program is executed, the output will be as exception colon java dot lang dot arithmetic exception colon slash by 0 and after catch statement.